Hello everybody, this is your first video of semester 2. We ended semester 1 doing confidence intervals and hypothesis testing with proportions. What we're going to do second semester is we're going to do confidence intervals and hypothesis testing with means. The difference between testing with proportions and testing with means is that when we test with proportions, we're using categorical data. We're using data that we are labeling by color, shape, etc. When we are using the normal model with means, we are using quantitative data, speed, temperature, weight, etc. When we use our normal model, we have to define which model we are using. For example, when we did our proportions, we would say the normal model given P hat and then standard deviation PQ over N, correct? So what we're going to be doing with our means is we're still going to be naming that normal model, but we're going to be naming it with our mean and our standard deviation, which as you see here is the standard deviation of the population over the square root of N. This value has to be known. If I don't know the standard deviation for my population, I can't continue with an analysis of means. As with our proportions, we also have our assumptions and conditions. You remember the first couple. Independence, very good. Randomization, very good. Okay, so that one doesn't make any sense. Why would we do NP, NQ if we're no longer working with proportions? So NP, NQ are out. The 10% condition is still in place. Very good. There is a fourth condition or assumption for working with means. This is called the large enough condition. It's all about context. You have to look at the situation you're in and decide how large a sample size do you think you need to have a fairly normal distribution. For example, let's talk about the lifespan of a mouse. Is the lifespan of a mouse normally distributed, or is it skewed, or what do you think we would have to do? If I have the lifespan of a mouse, let's just draw a little mouse here. I can say that yes, the lifespan of a mouse is pretty darn normal. We've analyzed so many mice over the course of however many millennia we've known them that we can say yes, with a fairly small n, I have a large enough sample size to assume that I have a normal model. So I could say my n is as low as 25. Now, what's a situation where I would need a much larger n before I could start looking at having a normal model? Well, what about executive salary? Now remember, an executive is anyone at the top end of a company. So we could be talking about anyone from Jeff Bezos to Miss Ayers. They are all executives. But I'd say that their salaries are pretty spread out. So since the executive salary is going to have so much variability in it, in order to get to a normal model, we have to rely very heavily on that central limit theorem. And the central limit theorem says the more samples I take, the bigger n is, the more I approach the normal model. So if I'm talking about executive salary, then my n is going to need to be something like maybe 200 before I feel confident using a normal model. Or my executive salary needs to be just only principals of high schools in Colorado. So I either need to have a much more defined grouping that I'm analyzing, or I need to say I need a much larger sample size in order to address that. So I'm going to write a couple. I want you to think about this. I'm going to write a couple down and I want you to give me a hypothesized sample size.